Hi, today we're going through the PAT paper from 2012, looking at question 12. So question 12 asks us to sketch y equals 1 minus x squared all over x squared. So let's start by finding the zeros of this function. So let's say that y equals 0. Okay, well clearly this is going to happen when the numerator is 0. So this implies that 1 minus x squared equals 0, or x squared plus x minus 1 equals 0. This doesn't factorize nicely, so what we do is we quickly just check our values by plugging them into the quadratic formula. So doing that, we get, well, we know we have a equals 1, b equals 1, and c equals minus 1. So we plug that in, we get, well, minus b, so minus 1, x equals minus 1, plus or minus the square root of b squared, 1, minus 4 times 1, minus 4 times minus 1, plus 4, so 1 plus 4, 5, over 2a, 2. So we see we're going to have one positive and one negative. Okay, fine, so we have our roots. Now let's check the stationary points. So let's rewrite y as, well, 1 minus x squared over x squared is 1 over x squared minus 1 over x minus 1. So this implies that y prime, dy by dx, is, well, derivative of 1 over x squared is minus 2 over x cubed plus 1 over x squared. So y prime equals 0. Well, this tells us that minus timesing through by x cubed minus 2 plus x equals 0, or x equals 2. So we have a stationary point at x equals 2. So we found zeros and derivatives. So now let's find the limit as x tends to infinity. Let's set x tends to, first of all, infinity. What do we notice? Well, looking at our y in this form, this is going to go to 0, this is going to go to 0, and this is going to stay. So we're going to have basically y tending towards minus 1. Is it from above or below? Well, so this is going to be a positive term, and this is going to be a negative, but it's going to be smaller than, it's going to be larger, sorry, than this 1 over x squared, because the x squared will tend to infinity much faster than the 1 over x. 1 over x squared will tend to 0 faster than the 1 over x tends to 0. So we're going to have it tending to minus 1 from below. Well, let's let x tend to minus infinity this time. Well, again, we're going to have 0, 0, minus 1. So it's going to tend towards minus 1. But this time we're going to have, well, that's, again, this is going to go to 0 faster than this. But this time, this is a positive term, minus, plus another positive term, minus 1. So it's going to tend to minus 1 from above. So let's bracket these from above and from below. Okay, well now we have pretty much everything we need, apart from our last point, which is that clearly we can't have x equals 0, so I'm dividing by 0. So x equals 0 is an asymptote. So what we're going to do is we're going to scroll over here and sketch on our function. So let's draw some axes. So there's our x-axis, and here is our y. X, y. Okay, well we know we're going to have an asymptote at y equals minus 1. So that's y equals minus 1. We're going to have one at x equals 0, as we know. And we're going to have some value we've worked out on our negative root, and we're going to have a positive root. And we're going to have some stationary point at x equals 2. So that's x equals 2. We'll call this alpha, and we'll call this beta. We've worked out alpha is minus 1 minus root 5 over 2, and beta is minus 1 plus root 5 over 2. Okay, well we said as x tends to minus infinity, it's going to tend to minus 1 from above. So it's going to come from here up through alpha, and what we know is going to be dividing by 0. So it's going to be asymptote, so it's going to go up like this. So we know the shape for negative aspects. So we come like this, pass through alpha, and approach smoothly an asymptote up to x equals 0. Okay, well clearly it's going to come back down, and we know it's going to be an intersection here, and we know it has to tend to minus 1 from below. So this means, well, it's probably going to come down here. We have to have a stationary point here, and clearly it's going to have to be a minimum. So it's going to have a minimum there, and then come back up and approach minus 1 from below. So we're going to have something along the lines of this. So coming down, striking our root, having a minimum, let's do that again, having a minimum at x equals 2, and then coming and tending to minus 1 from below. So we have our stationary point here at x equals 2. So that would be our graph.